Hello, Coach Travis here with another pre-calculus video. So this video is about exponential functions, and it's really kind of an interesting problem here. So what we've got is we want to construct the exponential function that goes through the points 0, -6, and 2, -54. And I guess when they say construct, what they really mean is find the formula. So find the formula for the exponential function that goes through these 2 points. So kind of the idea is we know that an exponential function looks like a times b raised to the x power. And so we need to figure out what's the value of a and what's the value of b. That's what we're trying to do. And the only clue we have is we know these 2 points. We know the point 0, -6 is on the graph, and we know that 2, -54 is on the graph. So actually, if I could be so bold, I might go ahead and sketch the graph of this thing, because we know kind of what exponential functions should look like. I'm going to probably draw a terrible picture here, but we know that exponential functions have a certain shape. And so this particular exponential function, and the x-axis is always a horizontal asymptote. So I'm going out on a limb, and I'm predicting that our function should look something like this. And the fun thing is once we find the answer algebraically, then we'll use GeoGebra to check our answer, and that'll be fun. I always like to see if I can guess what the answer is before I find it. And then when I find it, I can either say, hey, good job, I predicted it. Or I could say, oh man, I really got that one wrong. I learned something, and remember, making mistakes is important. And so I learned something. I was like, oh, I was thinking it was this way, but it's actually this way. Oh, okay, I learned something. All right, so anyway, but enough of me yakking. So let's, how the heck do you solve this problem? All right, so let me, I need some room to do some algebra here. So here's what we know. Yeah, what we know is we know that f of x is equal to a times b to the x. And we know that because we know that we're dealing with an exponential function. Okay, well now let's think about what the problem tells us. The problem tells us that, hey, it gives us a couple points. And a couple points mean input and output. So what this first point is telling me is it's telling me that when I put in 0 for x, then I get -6 for y. That's what this first point tells me. When 0 is the input, then -6 is the output. And so that's awesome, because that means, because b to the 0 I know is 1, so I now know I'm halfway done. We now know that the a is actually -6. Just like that, we figured out that the a is -6. All right, cool. So now let's, so now that I know that a is -6, everywhere I see an a, why don't I replace it by -6? So all right, so put a -6 here. And I apologize if my 6's look like b's. Yeah, b's and 6's look very similar. But this one's a 6, this one's a b. All right, so now what? Okay, well now I've got another point. Let's use our other piece of information. Our other piece of information is that when x is 2, then when x is 2, then the output, why did I write 2 pointing to 2? That's not particularly helpful, is it? I meant to put x. So when the input is 2, then the output is negative 54. So I can say that negative 54 is equal to negative 6 multiplied by b to the second power, right? Because when x is x, we're setting x equal to 2, and we're setting y, or the output, equal to negative 54. And okay, great. So now I can divide both sides. I can now divide both sides by negative 6, and that's going to give me 9 is equal to b squared. And if you think about that, what number can I square to get 9? Well, I guess you'd say that b, if you were doing it right, you'd say that b could be plus or minus 3. Okay, but not so fast, because remember that we're dealing with an exponential function. And one of the rules of exponential functions is that the base can never be negative. So algebraically, b could be equal to negative 3. But because of what we know about the problem, we can rule out the negative answer. So all right, so I think we're done. We now know that our function, let's clean this, let's clean up some space here. We know that a is negative 6, and we know that b is 3. So the claim is that our function is negative 6 multiplied by 3 to the x. But now the fun part. You might think you're done. You might think we're done, but no, I have to do the fun part now. And the fun part is using GeoGebra to check my answer. So there's GeoGebra, and let's graph this. Let's graph this function. Let's graph y is equal to negative 6 multiplied by 3 raised to the x power. And so there you go. You can see it on the screen there. It's not perfect. You know, my hand is shaky, so I can't draw. And I sort of, I didn't get the curvature quite right. But I think I did a pretty good job. So we predicted the curve should look kind of like this blue, and GeoGebra confirms that it looks like that blue. And the really important thing is that GeoGebra confirms that it goes through the 2 points that it's supposed to. So there you go. So that is how, if someone walks up to you on the street and they hand you 2 points on an exponential function, then you can use algebra just like we did to find the equation of that exponential function.